Hello students, today we are going to start the second topic in the syllabus of ICSE chemistry, that is chemical bonding. So first chapter is periodic table and second one is chemical bonding. So before I start the chapter and I talk about this chapter, first you should know the electronic configuration of elements from atomic number 1 to 20, okay, up to calcium, because this is a very fundamental thing and this we have seen in periodic table also. So this has huge application in periodic table and chemical bonding. Especially we will see in this chapter about valence electron. What is valence electron, children? The electron in the outermost shell. Just I'll talk about it. So before I talk about syllabus, let us see, and this you should learn by heart. This should be at your fingertips. Electronic configuration from elements starting with hydrogen. I'm using symbol and we end with calcium. Beyond calcium you need in your class 11 and 12. And even if a question comes, they give the electronic configuration and other data. So hydrogen is 1, helium is 2. This is a rare gas. Here we will see there are 3 rare gases, inert gases or noble gases. Carbon is 2, 4. We have a separate chemistry called organic chemistry. We will see carbon is tetravalent, and the last chapter is organic chemistry. We will see carbon and its compound. It has in the world 99% of compound out of 100 has carbon in it. Next is nitrogen 2,7, oxygen 2,6, fluorine 2,7, and this fluorine is a halogen we will see. 2,8. So 8 we will see is a stable structure, neon. Sodium is 281. Just first thing I'll start with that. Then we will see magnesium. So this is all what we need in this bonding chapter. What tick I am putting, they are very much needed, children. Okay. So magnesium is 282, aluminum is 283, silicon is 284, phosphorus is 285. So from here it has only one orbit, this has 2 orbit. So after neon we have 3 orbit. Sulfur is 286, chlorine is 287. This is very important, 1 electron short. Argon is 288. This has a stable structure of last orbit 8. Helium has 2 duplet. So every element tries to go to the electronic configuration of helium or neon or argon. Okay, helium, neon or argon. 8. Then potassium is 2881. Okay, and calcium is 2882. So this is what we need at least for periodic table. And so once more, hydrogen is 1, helium is 2. This is a stable inert gas. Lithium is 2, 1, beryllium 2, 2, boron 2, 3, carbon 2, 6. So tick ones are more important. Nitrogen is 2, 7. This is also we need in this particular chapter. Oxygen is 2, 6. Sodium is 281. So just to show you a diagram of sodium in short, I'll show you. 281. So you draw nucleus. We are not very much interested in nucleus, but it has 12 neutron and 11 proton. If you see, it has 11 proton and 12 neutron and 2. So you can put cross. It's quite easier, children. 2, 8. Drawing a circle takes time, so sometime I prefer cross for electron. 2, 8, and if you see last orbit, it has 1. So this is what an atom looks like, 281. But here when we do electron dot diagram, We are just interested in the valence shell, the outermost shell. We are not interested in 2-8, we are interested in this one electron in the last orbit, 2-8-1. The last one is 1. So we are more interested in this. So atomic structure diagram, we take the full atom, but in electron dot diagram, we draw the last orbit. So just next topic I'll take is sodium chloride, where I'll show you sodium. And if you want to see chlorine, children, chlorine has a nucleus. It has 2, 8, 7. 2, 8. Generally we draw in pair, but in reality, so 7. 1, 2, 3, 4, 5, 6, 7. So what we will see when this electrovalent bonding will take place, one of this electron from sodium will be transferred to chlorine, so it will become 288. It is 287, so it comes to the configuration of argon nearest inner gas, 288, it becomes stable. So when at the last orbit it has 8 or 2, okay, so it becomes stable. And sodium by losing one comes to the configuration of nearest inner gas, neon. So chlorine by gaining one goes to argon 288, it is 287, and sodium by losing one, 281, this one it does not share, electron is shared in covalent. So next topic we'll see electrovalent, where it is transferred. So sodium will give one to the chlorine and sodium will come to the nearest inner gas, neon. So this is the basic thing we start. So kindly pause the video and copy, then we will go to electrovalent bond, then covalent bond, then coordinate bond, and we will see characteristic. So kindly copy. So children, one small thing you can do here, rather than writing N, I wrote N for nucleus. So nucleus has proton and neutron. Neutron is neutral 0, and these are the electron. We can write like this, E negative, children. Okay, this is 1. So E negative, okay. So this I can write Na because this is sodium, and this N we can write Cl. So we know that it's chlorine. So nucleus, so we can identify the atom. So another thing, in just short I'll revise before I go to the next topic. So you know, atomic structure is based on the solar system model, as we have sun around which the planets move. So here sun, okay, is the nucleus, which has positive charge because of proton, and the electron revolves around like the planet. But generally in our solar system there is one planet in one orbit, but here first orbit we have 2, second orbit we have 8. So something like this also we write, sodium is 2311. On top generally we write mass number, 23 is sum of proton and neutron, and generally down one is atomic number, which you can say either number of proton or number of electron. So this is chlorine, also we write chlorine 3517. So there is another isotope of chlorine we will see later on. So this is chlorine 35. In fact, the number of electron remains same in the valence and other orbit, only the number of neutron changes. If you see isotope, they have different number of neutron, not the proton and electron. So now we move on to electrovalent compounds. So next we move on to the syllabus. So if you see the syllabus of ICSE, we will see we have electrovalent bonding, some electron dot diagram. This is what next thing I am going to do. There are 3 electrovalent bonding, electron dot diagram we will do. There are 6 covalent bonding, where we will do electron dot diagram, okay. And there are 2 polar covalent, children, we will see HCl and water. Okay, we will see polar covalent bonds, electron dot diagram. Then there are 2, 3 coordinate bond, and there is something extra in the syllabus where we will see the characteristic property. Okay, like you will see electrovalent bonds are very strong bonds. Okay, they are electrical in nature. The charges are there. They attract each ion attract the other with lot of force. Covalent bonds are not so strong because here we will see word sharing. So two word you remember children over here. Transfer, electrovalent bond, there is transfer of electron. Just I'll teach you by 3 example. Then we have sharing of electron and covalent bonding. And then we will see how polarity develops. So here you need some basic idea of electronegativity from chapter 1, which I'll explain it to here once more. Okay, what is electronegativity? Because without that, it's difficult to understand polar covalent bond. And last but not the least, we have coordinate bonding, hydronium ion, hydroxyl ion and ammonium ion, how we draw, and there are some other thing in the chapter. Basically we have this and characteristic property and few lone pair things we have, which we will see as we go ahead. So this is my part 1 of video on bonding. You may have 1 or 2 more part that we will see. So here we go children. We start with sodium chloride. See, as I told you before you start, so what you do children, you write element, okay, basically symbol and its electronic configuration before you start, like sodium chloride. Sodium is 281, chlorine is 287. So we are more interested here children in the valence electron, the last orbit. First orbit has 2, second orbit has 8 and the third orbit has 1, 7. So actually what happens, as I have told you earlier, sodium will give 1 to this. So after transfer what will you see? This will become 2,8 neon configuration and this will gain 1, this will lose 1 and this will come to the argon configuration. So when they reach the nearest electronic configuration of the nearest noble or rare gas, they become stable. So here we go. So sodium, another small thing children we note, generally in this chapter, please note this, we use dot for showing electron and cross also. You will see book has cross. Okay, this is cross and this is dot. So I will make use of this. Generally electrons are same, but we represent for our convenience. I'll tell you like here. See here, sodium has 1. I'll use a dot. It reacts with chlorine. Chlorine has 7. So I use a cross children. And see the positioning also I'll tell you. How we position it. See this will be transferred. See the word over here. Transfer. First 3 molecules we are seeing, they transfer, they give totally. But later on, next 6 we will see sharing. Then 2 we will see polar covalent and 3 coordinate bond. So dot and cross we show for electron. What is the trick I use over here? If drawing a dot, no, you have to darken it. So dot takes more time and cross we do very easily. So what we do children, wherever we have more number, understood, where we have more electron, I will be using cross. It's very easy. And where there is less, I will be using dots. Because see dot I have to make it little prominent. You just cannot give a dot. It's a darkened circle in fact. Saying a dot is, so it should be very prominent. So see here, I have applied my idea. Sodium has 1, 281, we are interested in this. And chlorine has 7, so 7 I have used this. Now, so here there is a transfer children. So here you can go, if there is a place, I come down over here. So sodium becomes positive by loss of electron. What is actually happening to this? If you see the diagram which I have drawn, atomic structure, it has 11 proton now. But it has 10 electron, 1 electron it has given. So finally what happens children, if you see it has 11 proton and 10 electron now. In the beginning, if you see my diagram, both were 11. 281 and inside 11. So there is surplus of 1 proton. 10 positive, 10 negative. They are equal in charge. Maybe masses are different. So 1 excess positive, which charge we have. So it becomes sodium positive. And this, if you see diagram, dot here. See how I use. You can practice. And it's very easy, children. and by gain of one electron it becomes negative. Why? It had 287, so it had, if you see chlorine had, if you see 35, 17 proton and 18 electron, that is neutron, that is another thing, but it had 17 electron also. So when it gains one electron, children, 288, 18, it gains one electron from sodium. So it gets 18 electron, but it has 17 proton. So one electron is extra. See the electronic configuration. 287, I said it gets one from sodium. So it gets 288. So chlorine becomes negative. This electron has been transferred from sodium to chlorine. And this, children, you can draw in one line, becomes sodium positive, and this becomes chlorine negative, and opposite charges. There is a huge attraction. This dotted line shows a huge electrostatic attraction, means electrical in nature. They are charges still. So positive and negative are very tightly bound. Okay, and hence now we get sodium chloride molecule, where one atom of sodium combines with one atom of chlorine by transfer of one electron. So children, this is what we have basically we call electron dot diagram. This you show, this you show, you come here. You can cut short one step, but generally it's better to do. So this is electron dot diagram of sodium chloride. Sodium, chlorine, sodium transfers one, it becomes positive. Chlorine gains one, becomes negative, and we have attractive force between them, and we get, and this sodium chloride, children, common name is common salt, which we use every day in our kitchen. Without salt you cannot eat most of the things. So what you eat salt at home is basically 99%, I think, sodium chloride. Next we move on to your magnesium chloride. So same thing, children, you write symbol EC, magnesium 282, chlorine as we have seen is 287. So one thing before I start, magnesium one atom can give 2 electrons, but one chlorine can take 1. So see here how we draw so easy. So this 2, if you see, so magnesium can give 2. So since it is less, and then now see here we need 2 chlorine. Okay, chlorine has 7, so 1 chlorine needs 1. See, so 1 magnesium can give 2 electron, but 1 chlorine can take 1 only. So for 1 magnesium we need 2 chlorine, because 1 chlorine can take only 1. It can become 8 only. So you need 2 chlorine. Basically this another chlorine. So this one will come over here and one will come over here. Okay, so don't draw arrow over here and all. So this we separate. Now what happens, children? Magnesium by loss of 2 electron becomes 2 positive, because it becomes 2, 8, 10 electron and 12 proton, as I have explained in previous one. Its proton remains 12, but electron becomes 10. And this chlorine, see how I write 2 Cl, okay, let me write it little left, plus 2 Cl negative. 1 chlorine will get 1 negative only. So I have 2 chlorine atoms. See the writing style, children. Magnesium becomes 2 positive and 2 Cl negative. So this becomes MgCl2. So very basic reason is, if you have done in class 8 what we call crisscross method, now I am giving you reason. See here. So we used to interchange the valency. If you remember class 8, this was called find the formula of magnesium chloride by crisscross method. We know magnesium's valency is 2, outermost electron, whereas chlorine is 1 short. Valency minus also we say means it will receive electron, it is 1 less than 8. So this is what we used to do. We used to write valency of chlorine here and magnesium here. What is the meaning of this? Now we understand that magnesium wants to give 2, but whereas 1 chlorine can take 1 only. Magnesium can give 2, but 1 chlorine can take 1. So we need 2 chlorine for 1 magnesium. So this is the reason for crisscross method, which you did in class 8. Interchanging the valency. Valency of chlorine comes here, magnesium comes here. This is the main reason. Okay, next also, when we do children, calcium oxide. So calcium oxide, how we do, you see? So like before, we write symbol CaO. Electronic configuration is 282, 2882 and 26. So oxygen, if you see children, is too short to get 8. See the black color, and this has 2 surplus. This will lose 2. Minus means lose 2, and but it becomes positive ion after loss. Okay, so Ca, see here nicely, has 2 electron children, and oxygen C has, I will use same color but I will use a cross. It has 6 electrons. Calcium, 1 calcium can give 2. 1 oxygen can take 2 because it is too short. So what happens? Calcium becomes 2 positive and oxygen, see here this diagram, 1, 2, 3, 4, 5, 6. This 2, what I am showing with black marker, is electron transferred from calcium to oxygen. So becomes, oxygen becomes 2 negative. It had 6, it becomes 8. Means now it has 8 electron and 10 electron and 8 proton. Proton remains same 8, but it has now 10 electrons. So 2 electron surplus, and this is 2 electron deficient. Okay, 288, and it comes to the nearest argon configuration by losing, and this comes to neon configuration by gaining. So finally what happens children? Next step, there is attraction between calcium and oxygen, and we get calcium oxide. So calcium oxide, 1 calcium needs 1 oxygen. So if you remember class 8, calcium and oxygen, this is what was taught. Both the valency is 2. It has 2 surplus. This is too short. So we used to interchange valency and we used to cancel before. So we used to get CaO only. Why we used to cancel? Now you know. Calcium can give 2, like magnesium can give 2, but chlorine can take 1. So we need 2 chlorine atom. But here calcium can give 2, but oxygen is too short, unlike chlorine. Chlorine is 1 short, 1 less. Short, not SHOT, SHORT, short. This is too short of 8. So both will be given to oxygen. This will become 2 positive, this will become 2 negative. So 1 calcium needs 1 oxygen for getting stable inert gas configuration. This becomes 288, argon configuration 18, and this is 28 neon configuration, because every element tries to come to the nearest inert gas configuration, but 11 and 12 you will see sometime there is exception to this rule also. You'll have to wait till class 11 and 12. Okay children, so in this video I'm just doing electrovalent compound. This video is becoming bigger. In the part 2 of the video, just I'll show you 6 covalent compound, and maybe in third part I'll explain it to you the polar compound and coordinate compound, and maybe I'll see characteristic and some other thing in part 3 or part 4 of the video. So kindly practice children, and thank you for watching this part 1 of chemical bonding.